Now let me give you an example how to connect your circuit to set up your op-amp as a comparator. Now remember that the op-amp must have similar supplies for positive and negative, similar values. If it's positive 9, it's negative 9, positive 15, negative 15, remember? These are supply voltages, right or not? So how you connect into your circuit to give you identical values, but one positive, one negative? The trick is by using two sets of identical batteries. Two battery of cells. Make sure, like for example, if this is 9 volts, this also must be 9 volts. And then the technique is to earth the center. That means in between these two cells, which is here, you earth it. So if you earth it, what is the potential here? 0 volts. So therefore, what's the potential here? 9. So therefore, what's the potential here? Do you agree not?
Yes.
Okay. So therefore, can you see your negative 9 is connected to here?
Yes.
So therefore, your negative supply is negative 9 now. And your positive supply will be positive 9. So if you want 12 and negative 12, no problem. Just change this to 12 and 12. You want 15, negative 15, 15 and 15. So you always get the same values for top and bottom. Do you understand that? Now, what about the inputs? Remember the input, we only want the voltage, but we don't want current. So what do? This example has two sets of potential divider. The first potential divider is made out of two similar resistors. So let's, for the sake of discussion, take the values. What is the potential here? 9. Here? Here? 9. What about here? Here? Okay. So can you see that the 9 volts will be divided between these two? So each of them will take how much? But we must always take the PD from the 0 side, 4.5 volts, to get the potential at this point, right now. So this point also has a potential of 4.5 volts. So this becomes your V minus. Because can you see it's connected to the inverting input here? So your V minus is 4.5. But will any current flow in? No, current just flow down like that. Understand that? Because why it cannot flow in? Remember the assumption is infinite input impedance. Okay, so no current enters. Now the second potential divider made out of another resistor F and an LDR. So let me show you what happens. What is the typical resistance of an LDR? Between, let's say, 1 ohm to 100,000 ohms. And when is it 1 ohm? When it is bright. And when it's 100,000? Dark. So let's say when it's bright, right? When this is bright, the resistance here is low. So the PD here is small or big? Remember the 9 volts is split between these two? If this bright light condition, this is very small resistance, it takes small PD or big PD? Small PD. So let's say for example it takes 2 volts. Example. So if it takes 2 volts, then this becomes your V plus. And the output for a comparator, remember the formula? If it's DC, it's 10 to the power 5 gain. V plus minus V minus, right? So therefore, you will notice that if you substitute your V plus as 2, V minus as 4.5, you get positive or negative? So you get negative saturated. So you don't have to show any calculation. You say the output is negative 9 volts. So then you get the negative 9 volts. So this is when it is bright. Okay. But when it's dark, what will happen is the resistance, the LDR, will increase. So you will carry more PD, right? So let's say the PD shoots up to 6 volts. Then you substitute into this equation. Your V plus is 6 now. V minus is still 4.5. You get positive or negative? So now you get positive 9 volts when it's dark. Agree not? So what do we do with this output? Okay, so there are two output devices that you learn, either the LED or the relay. LEDs are simple. LEDs are just to indicate whether it's bright or dark. So you just see the LED, if you see red, oh, that means outside is dark. Or outside is, if it's red LED, you can choose lah. You want it to be dark or bright? Dark. So when it's green LED, bright. That means you can go out lah. Okay, can. So what you do, you have two LEDs. So the symbol for LED is just a diode with the light shining. Another one point up, this one. Now make sure you connect a resistor in series with your LED, because the LED can only take a very small current, otherwise then it will spoil already. 20 milliamp I think. So because of very small current, so you have to make sure that you put a resistor in series lah. Okay, so now remember you said when it's bright you want a green LED. So which LED should be green, the left or the right one? So how do we know whether it's left or right, right? Remember when it's bright, you get negative 9 volts here. So which LED will light up, the left or the right? You check and see which one is forward biased. Can you see this is 0 volts? So current now will flow through 0 to negative 9, right? So which one can it flow? Can it flow across your LED like this if the diode here is reverse biased? But this one can flow, right? So therefore, this is the one that must be. This will be the one that will be green. So this will be a green LED. So because when it's bright, your right side will light up. So therefore, it's green LED. But when it's dark, your output is positive 9. So if this is positive 9, this is 0, current will flow this way. So through this LED cannot flow. So it will flow through this LED. So when it's dark, this one lights up. So therefore, this is red. Okay? So you can actually replace this with a relay if you want to, instead of turning on and off the LED to show you whether it's dark or bright. Let's say you want it to turn on external light. That means a porch light. So let's say at night, automatically it turns on when it's dark, and in the morning it automatically turns off. Then you don't use LEDs, you use relays. So if you want to connect a relay, right, to turn on the light, so this is how you connect it. You put the relay here. Now what is a relay? A relay is actually a solenoid. The solenoid, you must put a diode first. Then you put your solenoid here. Then you put your switch here. Okay, so this is your relay switch. Then you connect to an external light source, let's say a battery, and then you connect to a lamp. Okay, so that is your light source, a lamp and your outside battery. So this is what will happen when it is bright, right? When it is bright, this is negative 9 volts, this is still 0 volts. So if it is 0 volts, can current flow from here to here now? So that means no current flows. What will happen is this relay coil is not activated. But when it's dark, this is positive 9, this is 0, your diode is pointing down, can current flow? When the current flows, this solenoid will become magnetized, so it will pull and close the switch. So when it closes the switch, then you turn on the light already. Alright, so we can use it in a relay later on, but it's the same input circuit here. Okay.